Hi, this is Mrs. LaBarbara. This is Regents Physics Chapter 2, Video 7. Today's lesson is Newton's second law. The objectives for today is to know equation for Newton's second law, to understand how acceleration is related to net force and mass, be able to determine acceleration, net force, or mass, and use acceleration, net force, applied force, and or friction force to determine the unknown quantities. Newton's second law regards when the forces are not balanced. When the forces are not balanced, the object has acceleration. This acceleration depends upon two variables, net force and the mass. The acceleration of the object depends directly upon the net force, in the same direction as the net force, and inversely relate to the mass. So when the forces are not balanced, there is an acceleration. That's Newton's second law. The acceleration depends directly upon the net force in the same direction as the net force. You see directly means when one increases, the other increase. When one decreases, the other decrease. The acceleration depends inversely upon the object mass. That means when the mass increases, acceleration decreases. When mass decreases, acceleration increases. Equation for Newton's second law. Acceleration, just as it states, is directly proportional to the net force, inversely proportional to the mass. This equation is in your reference table. You rearrange it, you can write down net force equals to mass times acceleration. Note in both equations, the force is the net force. See the net here? It's a net force. Acceleration is directly proportional to the net force. The net force equals to the mass times acceleration. So this equation, F is just not any force. It has to be all the force added together. That's a net force. The resultant. The acceleration of the same acceleration is in the same direction as the net force, and acceleration is produced by the net force only. 1 Newton is 1 kilograms times the meter per second squared, because F equals ma, unit for m is kilograms, unit for a is meter per second squared. So this is a derived unit. How big is 1 Newton? The weight of an apple is 1 Newton. Let's do some practice. You are given the net force and mass. Acceleration is net force divided by mass, so that's 5. Net force divided by mass, 10. Net force divided by mass, 5. Net force equals mass times acceleration. So over here you have 10 newtons. Mass equals to net force divided by acceleration, which gives you 1. Let's take a look at this relationship. If mass is constant in situation 1 and 2, when you increase the force, when you double the force, acceleration doubles, because force and acceleration are directly proportional. Now, in the case of 2 and 3, when the net force is constant, if you double the mass, acceleration halved. That is because acceleration and mass are inversely related. Graphs of acceleration versus net force and acceleration versus mass. Acceleration is net force over mass. So acceleration and net force has a direct relationship. Direct relationship is a straight line. Acceleration is inversely related to the mass. That is a curved down relationship. Applying Newton's second law, acceleration is F net over mass. This F net is the sum of all forces. This sum is a vector sum. That means it includes direction. Pay attention, F sub n, capital N, is not F net, even though both start with n. This one is net force, this is normal force. The 3 major equations that will be used for other equations for net force, gravity, and friction. Practice 1. An object is moving horizontally. Use a diagram to determine the normal force, the net force, the mass, and acceleration of the object. Use g equals 10 meters per second squared. Since the object is moving horizontally, that means in vertically it is in equilibrium. So if gravity is 80, abnormal has to be 80. Also, I can use W equals mg to figure out m. M equals W over g. 80 divided by 10, I get 8 kilograms. Next one, net force. Net force is a vector sum of all forces. Net force equals to the right, positive 50 plus to the left, negative 10. So net force is 40, direction is to the right. Acceleration is net force divided by mass. 40 divided by 8 give you 5. Its direction is the same as the net force. Practice number 2. An object is moving horizontally. Use diagram to determine the normal force, the net force, the mass, and the acceleration of the object. So again, it's moving horizontally, so vertically it's balanced. That means if gravity is 100 newtons, normal force has to be 100 newtons. If gravity is 100 newtons, mass has to be 10 kilograms. Now to the left, you have friction 10 newtons. To the right, you have applied force of 20 newtons, so your net force has to be 10 newtons. To the right, 10 newtons is 20 plus negative 10, vector sum of all forces. Next, if you know the net force and you know the mass, you can figure out acceleration using the equation net force over mass. 10 divided by 10 give you 1. The direction of acceleration is the same as the net force, so it's 1 meters per second squared to the right. To find mu, we use the equation mu equals ff over fn. This is derived from ff equals mu times fn. So mu equals 10 divided by 100 give you 0.1. Practice number 3. An object is moving horizontally. Use the diagram to determine the normal force, the net force, the mass, and the acceleration of the object. Use g equals 10 meters per second squared. So again, vertically, it's in equilibrium. If I know the mass, I can figure out the gravity by using W equals mg. That gives me 50 newtons. Normal force, therefore, is 50 newtons. I know mu equals 0.1, so friction equals mu times normal force gives me 5 newtons. Next one, I can figure out F net, because up and down cancels out. So all you have left is the force to the left, which is friction force. So F net is negative 5 newtons. Negative means to the left. Net force is 5 newtons to the left. Lastly, I can figure out acceleration. Acceleration is net force divided by mass. It's 1 meters per second squared to the left, same as net force. Practice number 4. An object is moving with constant velocity. So again, to the right, determine the unknown force with direction. Use g equals 10 meters per second squared. So m is given to you. From there, I can figure out gravity. Use W equals mg. Normal force and gravity are the same because we assume the object is moving to the right, constant velocity. So up and down force should cancel out, regardless which direction it's moving. There is no acceleration, so vertical accelerations or any acceleration, so all the force should cancel out. Up and down cancel out. Left or right should also cancel out. Now let's see, net force equals ma. Since a equals to 0, net force equals to 0. Since acceleration equals to 0, net force equals to 0, so applied force has to cancel out. Friction has to be 50 newtons to the right. Next question, I want you to try to do this question on your own. Then you can compare with the answer. You can pause the video, then compare with the answer. So here are the answers. If you have a question, please ask tomorrow during the class. Here is the last one. Again, pause the video, try to do it on your own, then compare with the answer. That's it for today. Thanks for watching. See you next time.